Alright everybody, we are going to begin the next section, 5.1, by going over some of the basics of quadratic functions. Now, you've heard of a quadratic before. It's one of our parent functions, but we're going to expand upon the idea a little bit. By definition, a quadratic function is a function that can be, not that it always is, but can be written in the form f of x equals ax squared plus bx plus c. A, b, and c in this case are just numbers. So a lot of times we see a quadratic written like this. It's not always written like that. You'll kind of see as we go through some examples what I mean. But the important thing is that we could maybe do some algebra to make it look like this. So some characteristics some of you are already familiar with. You know that the quadratic's graph looks like a U. We actually call that a parabola. The highest exponent that you're going to see on x is 2. So if you were to see an exponent of 3, it's not quadratic. It has a vertex, and the vertex is pretty important. And you'll see why throughout the chapter, but the vertex is sort of the turning point, or the highest or lowest point on the graph. If we have a U shape, it's the lowest. If we have the upside down U, looking like that, then that vertex is the highest. And the nice thing that I like about quadratics is that the graph is symmetrical on both sides, and it has what we call an axis of symmetry. So it's sort of an imaginary line that we could fold on and have a mirror image on the other side. And you'll see what I mean in a second. So the first thing you want to be able to do is identify whether something's quadratic or not. And so I look at number 1. It's certainly not in the form right now of ax squared plus bx plus c, but if I were to FOIL these together, which is something that we know how to do, then obviously combine like terms, I would have 4x squared minus 21x minus 18. And that is in ax squared plus bx plus c form, so yes, it is quadratic. The next one, though, when I distribute the 4 here, I would get negative 8x plus 12. Well, that's actually linear. We don't have an exponent of 2 anywhere. So, no. It is not quadratic. And then the last one, we distribute the x squared, I would have 3x cubed plus 2x squared. I do have an exponent of 2, but I actually have one higher, an exponent of 3, so that actually means that that's not quadratic either. Okay, taking a look at the graph of a random quadratic function here. This arrow is actually pointing to the vertex. And if we look, it looks like the vertex is at, looks like it's at 2, 3.